Hi guys, welcome to Tech Combos YouTube channel. Hope you all are doing well and having a great day. Today I am going to discuss about computer architecture. Why to know about computer architecture? There are mainly two reasons. To have a better understanding on how computer works and its components communicate each other. What each component is meant for, how it is designed to work. Secondly, to design and develop the better code, which is in performance perspective. You will obviously do it because you know how the computer works. Let's move on. What is it? Computer architecture is a set of rules and methods that describe the functionality, organization, and implementation of a computer system. Computer architecture involves mainly the below operations: instruction set architecture design, microarchitecture design, logic design, and implementations. In instruction set architecture design, engineers would mainly working on defining the machine code that a processor reads and acts upon. For example, they might define 001 as add operation, 111 as a load operation, etc. And they also define word size, memory address models, processor registers, and data type, etc. etc. You might be aware of direct addressing, indirect addressing, and also you might have come across the name like AX registers, AC accumulator, PC program counter, etc. Knowing the purpose of all these would really help us understanding how computer works. This one I still referred from the below reference site. I really liked it, so sharing the same here. What computer consist of? What computer consists of? Computer consists of software and hardware. Computer architecture talks about how hardware and software are designed and implemented to work better individually and also together. Below shows the computer abstraction. Computer system spans many levels of details, which in computer science we call levels of abstraction. Operating system provides a convenient interface between the user and his or her application software and the hardware, sometimes called bare machine. Assembler translates assembly language, a primitive type of programming language, into a machine code, which is a stream of ones and zeros. Instruction set architecture interfaces the software to the hardware and provides support for programming. Processor, memory, and IO subsystems. These components support the execution of machine code instruction expressed in terms of ISA. Data path and control provides a convenient abstraction for connecting the processor, memory, and IO systems and controlling their functionality efficiently. What you are looking at is a 6 levels of abstractions layer, which we have seen in the previous slide in a detailed mode. For example, we'll start with the level 5, problem-oriented language. Provides a convenient interface and application engine that helps the user produce results specific to a given application area. For example, Microsoft Word is used to creation of the document and editing. Excel for accounting spreadsheet creation. The language at this level is usually a sequence of keystrokes or a high-level scripting language. In software design, the language is a high-level programming language such as C, C++, or Java. Level 4, assembly language. Assembly is a very detailed language that helps the system programmer or software designer move information around in a computer architecture in a highly specific way. For example, many compilers programs that translate programming language into assembly language and are written in assembly language. The assembly language's advantage is a speed and power in accessing various features of the hardware. Level 3, operating system machine provides a convenient interface between assembly language and the abstraction of a hardware architecture's instruction set. Operating systems generally contain many libraries that help a software developer or programmer to connect low-level system functions, IO, memory allocation, etc. in an organized way. Level 2, instruction set architecture. One of the important part of a computer is the interface between the lowest level of software and the hardware. The ISA includes anything programmers to make a binary machine language to work perfectly, including instructions, I/O, etc. The ISA facilitates the design of functionality independent of hardware. Level 1. Microarchitecture level. Micro instructions are low-level control instructions that define the set of data path control signals which apply to a given state of a computing machine. The micro instructions, together with their sequencing, comprise the microarchitecture, whose purpose is to rigorously and consistently express the control of logic circuits that comprise the computer hardware. Designing this control in terms of a program that implements machine instructions in terms of simpler micro instructions called microprogramming. Level 0. Digital logic. The circuitry that makes a digital computer run is called logic. All processes of a digital computer are expressed in terms of functions of ones and zeros, for example, and or not functions. I have included this abstraction in this session because to show the clear picture of computer architecture, it is important for us to know the computer architecture as a prerequisite knowledge before designing any code. Type of architectures. There are mainly two types of architectures, von Neumann architecture and bus architecture. Von Neumann architecture is the first architecture in the computer system and it is still being followed. It consists of five classical components: input, output, processor, memory, and data path. And in processor, we have ALU and CU. ALU, arithmetic logic unit, and CU means control unit. And this method is still persist on today's architecture as well. Within the processor, the ALU data path mediates data transfer for computation. Registers are very small storage elements present inside the processor and are fast memory modules from and to which data can be read or written to support streaming computation. Accumulator is one type of special register and it supports efficient addition or incrementation of values corresponding to variables such as loop indices. The von Neumann architecture has significant disadvantages. Its speed is dependent on the bandwidth or throughput of the data path between the processor and the memory. This is called the von Neumann bottleneck. Bus architecture. A bus architecture is a communication system that transfers data between components inside a computer. Bus-based computers are similar to von Neumann architecture, but it differs in design of connecting all the major components like input, output, processor, and memory into a buses that act as a superhighway for the data and instructions to move between the processor and memory. The primary operation of the processor is execution of sequence of instructions stored in main memory. The CPU fetches an instruction from memory, decodes the instruction to determine what operations are required, and then executes the instruction. And the control unit controls this sequence of operations in the processor. Here you are looking at three different buses: address bus, data bus, control bus. We have seen that bus is a communication system and transfers data between different components inside the computer. The data we are talking here are vary depending on the current instruction being executed. In CPU, we have many registers. Here, we have mentioned the very common registers. IR is an instruction register, holds the current instruction being executed. PC means program counter. It keeps track of next instructions to be executed. Also, it has a current instruction address as well. SP means stack pointer, which will point to the top activation record on the runtime stack. Whenever a function call is made, an activation record is pushed into a runtime stack. In reverse way, whenever a function returns, then the activation record is popped from the runtime stack by decrementing the stack pointer. MAR, memory address register, holds the address of main memory to or from which data to transfer. Handle the data transfer between the main memory and the processor. MDR, memory data register, contains the data to be written into or read from the addressed word of the main memory. Handle the data transfer between the main memory and the processor. Finally, the IAC means accumulator. It accumulates the results of instructions being currently executed by the processor. Instruction set architecture. It is one of the most important part of a computer. It is the interface between the lowest level of the software and hardware, which we have seen in some of the previous video. The instruction set architecture is the part of a processor that is visible to the programmer or compiler writer. The ISA serves as the boundary between software and hardware. The ISA of a processor can be designed using 5 categories. Operand storage in a CPU. Where are the operands kept other than in memory? Number of explicit named operands. How many operands are named in a typical instruction? Operand location. Can any ALU instructions operand to be located in memory? Operations. What operations are provided in the ISA? Type and size of the operands. What is the type and size of the each operand and how it is specified? I am requesting you to go through the internet for more and more information on these details, because again I'm highlighting here that my intention is to let you know that these are the important concepts we need to know. So there are many YouTube videos where these things are well set. So requesting you to go through those videos. Let's move on. An instruction set architecture is an abstract model of a computer. It is also refers to as a computer architecture or architecture. A realization of an ISA, such as a central processing unit, is called an implementation. In general, an ISA defines supported data types, registers, hardware support for managing memory fundamental features such as memory consistency, addressing modes, virtual memory, and input and output model. An instruction set architecture is distinguished from a microarchitecture, which is the set of processor design techniques used in particular processor to implement the instruction set. Processor with different microarchitecture can share a common instruction set. For example, the Intel Pentium and the AMD processor implement nearly identical versions of the x86 instruction set, but have radically different internal designs. Classification of ISAs. An ISA may be classified in a number of different ways. A common classification is by architectural complexity. There are mainly two architectures we discuss usually. One is CISC, another one is RISC. A complex instruction set computer has many specialized instructions, some of which may only be rarely used in practical programs. A reduced instruction set computer RISC has a small set of simple and general instructions rather than a large set of complex and specialized ones. The main distinguishing feature of RIC is that the instruction set is optimized for a highly regular instruction pipeline flow. Another common RIC trait is their load and store architecture, in which memory is accessed through specific instructions rather than as part of the most instructions. Let's see about what is instruction and what are the different instruction types. Machine language is built up from discrete statements or instructions. On processing the architecture, a given instruction can specify maybe a particular register, a particular memory location, a particular addressing modes. Instruction types. Examples of operations common to many instructions include data handling and memory operations, arithmetic and logic operations, control flow operations, coprocessor operations, complex operations. Okay, in this slide, we would be discussing about how computer program is being getting executed. On a traditional architecture, an instruction includes an opcode that specifies the operation to perform, such as add contents of memory to a register, and zero or more operand specifiers, which may specify registers, memory locations, or a literal data. Requesting you to have a look at the instruction diagram which I have mentioned here. Also, you can have a look at the sample sections I have given here. So the execution of an instruction is nothing but certain number of steps which is carried out by the central processing unit, which is nothing but a processor. So in general, I'm not going to explain all the 9 steps here. Please have a look at those quickly. What I wanted to tell you is that it is like a 3-step process where the CPU fetches the next instruction, and it decodes the instructions, and then it executes the instruction. This process will keep happening by the CPU. Yeah. So the rest of the things which you please have a look at it. Finally, I would like to suggest a good and useful reads about pipelining, memory, which includes cache and virtual memory, and parallel processing. Thank you so much for watching the video. We will see in the next video.